You have probably looked up at the night sky and wondered why the stars seem to move while you stand still. Most people never get an answer. But 1500 years ago, a young Indian mathematician sat down with nothing but his eyes, his mind, and a piece of palm leaf and worked out something so far ahead of its time that the rest of the world would not catch up for 1,000 years. His name was Aryabhata, and what he discovered should make every Indian sit up a little straighter. In the year 499 CE, at the age of 23, Aryabhata wrote a text called the Aryabhatiya. In it, he stated something that contradicted every belief held by every civilization on earth at that time. He said the earth was not standing still. He said the earth was spinning on its own axis, and that this spinning was the reason the stars appeared to move across the sky each night. Think about how radical this was. The Greeks believed in a fixed earth. The Romans believed in a fixed earth. For the next 1,000 years, most of Europe would believe in a fixed earth too. It would not be until 1543, when a Polish astronomer named Nicolaus Copernicus published his own theory of a rotating earth, that the West would even consider the idea seriously. And Copernicus did not do this safely. The Catholic Church saw the idea as heresy. Galileo, who supported the same theory decades later, was placed under house arrest for the rest of his life for saying it out loud. Aryabhata said it first. He said it a full 1,000 years earlier. And he was not punished. He was celebrated. But the rotating earth was just the beginning. Aryabhata also calculated the value of pi to an accuracy of 4 decimal places, 3.1416, using nothing but geometric reasoning. He did this centuries before algebra as we know it even existed. Dr. Rodam Narasimha, the renowned Indian aerospace scientist and historian of science, has written extensively about how Aryabhata's mathematical methods reveal a level of abstract thinking that simply did not exist anywhere else in the ancient world at that time. Aryabhata also calculated the length of a year on Earth to be 365.358 days. Modern calculations place the actual figure at 365.256 days. He was off by a matter of hours, working with nothing but careful observation and mathematics, 1500 years before satellites, before telescopes, before any instrument more advanced than the human eye. He explained how solar and lunar eclipses actually happen, not as omens or punishments from the gods, which is what most ancient cultures believed, but as the simple, predictable result of shadows cast by the earth and the moon. He calculated the circumference of the Earth with a margin of error of less than 1% compared to modern satellite measurements. Let that sit with you, 1%. In the 5th century, how did one person achieve all of this without modern instruments? Part of the answer lies in something deeper than individual genius. Aryabhata was working within a tradition of Indian astronomy and mathematics that stretched back centuries before him, through scholars at institutions like the great learning centers of Kusumapura, where mathematics, astronomy, and observation were treated not as separate disciplines but as one unified pursuit of truth. His work did not stay buried in India either. The Aryabhatiya was translated into Arabic in the 8th century, where it influenced generations of Islamic astronomers and mathematicians. Through that Arabic translation, fragments of Aryabhata's thinking eventually reached Europe centuries later, though by then his name had often been lost from the story, even as his ideas quietly shaped the foundations of modern astronomy. In 1975, when India launched its first satellite into space, the nation did not choose a generic name. It named that satellite Aryabhata, sending the mathematician's name into the very sky he had spent his life trying to understand from the ground. So the next time you look up at the night sky and wonder why the stars seem to drift while you stand still, remember that an Indian mind solved that mystery 1,000 years before the rest of the world was even willing to ask the question. He did not need an observatory. He did not need a telescope. He needed only the courage to trust what mathematics was telling him, even when it contradicted everything everyone else believed. Historians today still marvel at how a single mind, working without instruments, without telescopes, without a single tool we would recognize as modern science, could arrive at conclusions so precise that satellites would later confirm them almost exactly. That is not luck. That is not coincidence. You looked up at the sky and wondered. Aryabhata looked up at that same sky 1500 years ago, and he already knew the answer.